Hi everyone, I'm Brock. So today I want to introduce an academic paper called SDXL, Improving Latent Diffusion Models for High-Resolution Image Synthesis. I have read this paper before. So this morning, but I found that I forgot to show my screen, which means that in my recording, I only record myself, but didn't and failed to record the screen, which means that I need to redo it again now. So I want to do it quickly. So this is this is original paper. And let's see the report. Core functions. First one, text to image generation. SDXL's call functions to convert text description into high-resolution images. Two-stage refinement pipeline. SDXL uses two models working together, similar to a draft plus refinement creative process. For example, base model, just like a painter quickly sketching outlines. Refine model like a detailed specialist, improving features, background texture, and other details. Second feature, second feature, multi-aspect ratio generation. SDXL can generate images with different aspect ratio, not just the squares. Traditional model can only generate 512 times 512 square images, but SDXL support landscape, portrait, or square. Also provides size and crop conditioning. SDXL introduced two innovative control parameters. Such conditioning. We can tell the model what resolution this image should appear to be taken at. We can also control the subject's position in the frame. Core technology. Scaling up the model. SDXL's Unite has 2.6 billion parameters, 3 times larger than Stable Diffusion 1.5, which is 860 million parameters. Second technology, dual text encoder architecture. SDXL use two text encoders to understand text simultaneously, like using two eyes provides better depth perception than one. Feature 3, Fourier feature encoding. This technique converts integers, like image dimension, into continuous signals that neural network can easily understand. Feature 4, Latent Diffusion model, LDM. Instead of generating image directly in pixel space, it works in a compressed latent space, significantly reducing computation cost. Feature 5. Classic Fail-Free Guidance, CFG, a technique to control how closely the generated image matches the text prompt by mixing conditional and unconditional predictions. Feature 6. Multi-stage training strategy. SDXL uses simple to complex training strategy, gradually improving image quality. And here are some terminology in AI or machine learning areas, such as unite, which is a convolutional neural network architecture with a U-shaped structure, consists of a constraining path encoder and an expansive path decoder, connected by skip connections. Diffusion model, DM, a generative model that learns to gradually denoise data, starting from random noise and iteratively refine it into a large distribution through a reversed diffusion process. Feature 3, latent space, which is a compressed no-dimension representable data, which is semantically meaningful operations can be performed more efficiently than in an original high-dimension space. VAE, variational autoencoder. It's a type of neural network that learns to compress data into latent representation and restructure it back with a probabilistic framework that enables smooth interpolation in the latent space. Cross attention. An attention mechanism that allows one sequence to attend to another sequence, enabling the model to align and integrate informs from different modalities. 6. CLIP, contrastive language image pre-training. A neural network trained on 400 million text image pairs that learns to match images with their corresponding text descriptions through contrastive learning, enabling zero-shot image classification and text-to-image generation. 7. Transformer block. A neural network module consists of a multi-head self-attention layer and a free and feed-forward network originally designed for natural language processing, but now widely used in computer vision. FID score. Fresh at inception distance, a metric that measures the quality of generated image by comparing the distribution of features extracted from real and generated images using an inception network. DDIM sample, denoising diffusion implicit models, are deterministic sampling methods for diffusion models that enables faster generation by skipping steps in the reverse diffusion process while maintaining image quality. Offside noise, a technique that adds a small amount of noise with a non-zero mean to the training process, enabling diffusion models to generate image with very dark or very bright regions more effectively. System design and architecture. SDXL employs a module two-state architecture design, comprising text encoder, image generation, and refine modules. Detailed module design. First one is text encoding module, which is converting natural language into numeric vectors that a neural network can understand. Second part is conditioning embedding module, which is embed additional control signals into the generation process. Third part is unite backbone. It reactively deploys in latent space, gradually generating the target image. Pipeline. This is how the pipeline looks like. And this is how the inference workflow looks like. I feel that when I do it at night, I really get sleepy and don't have the patience to go into details. And a multi-aspect ratio training mechanism. Inner module data flow. Major milestones. The paper was first published on EXIV on July 2023. And it's get very okay. Okay, so it's a theory foundation for Coffee UI on GitHub. And the co-founders, first author is Dustin Padel, applied research scientist at Stable AI. And here are some business analysis. It's important, but I won't go into details at this moment. Key insights: the power of open source strategy. Insights 2: diminishing returns of model scaling. Insight 3: failure of traditional evaluation metrics. Business insights. Copyright gray area of AI-generated content. Double-edged sword effect on creative industries. Future trend prediction: single-stage high-quality modules will dominate. Text rendering capability will break through. Video generation next battleground. Implication. Yeah, that's pretty much about it. Actually, I didn't go into the details for a lot of technical details. But I basically I get some basic sense about what this academic paper is all about. It's actually the foundation of Stable Config UI. It's more like a more advanced version of Stable Diffusion, I think. Yeah, that's pretty much about it. And thank you, everyone. Bye.